Hello and welcome to presentation of CADS RC Beam Designer. This is part of the Smart Designer suite. The programs in this suite are all quick to learn, very simple to use. We're looking at the beam design program today, but there are other programs for various other elements in concrete that the videos are available for you to look at, and also cover steel. The programs are independent, as I've said. They're cloud-based, so you have the versatility of access through the internet. They're designed to BS8110 and EC2. You can swap from one code to the other if you need to. They can be linked into CADS A3D Max, our frame analysis program, so you could analyze a gridage of connected ground beams and then select those members, pass that through to RC Beam Designer for design, or indeed a multi-story concrete frame and link to column design, beam design, foundation design, pile caps, pad bases. We make a conscious effort to provide an output from our design programs in concrete to CADS RC so that the detail is as comprehensive, as practical as possible, so there are no edits, if any, needed whatsoever. So you'll see a lot of options in the programs for detailing. The programs are permanent licenses, they're not subscriptions, and they are available on rental if required. So the 5 programs in the Smart Designer suite for concrete are today's program, CADS RC Beam Designer, but then we have columns, pile caps, pad bases, and slab design programs. There are other videos on these. CADS RC Beam Designer, some of the key features: continuous beams or ground beams or foundations, standalone or linked to 3D Max. As I say, that would be a benefit of linking to 3D Max, is all the loads etc. would come through from the analysis rather than having to put it in as a standalone program. The detailing link is comprehensive, very automatic, and the scheduling comes straight from that. The program also has some of a unique feature in that, given a range of bar types and so on, the program will give you an automatic cage. You don't have to put the bars in specifically and then check them, but you can do if you want. So it's versatile. You can either get an automatic cage straight from the word go, or you can put in your own cage and check it. It's got an option to do both. And then of course, yes, say we have this CADS RC detailing link. The options for the different types of cage you can see on the right here. You can see all the sort of options within the program for detailing, and then down the bottom right you can see a detail that's been produced in CADS RC. So let's have a look at the program. We're looking here at CADS RC Beam Designer in standalone mode. The user will have to put in geometry, loads, calculate the combinations, and run the analysis. That's a stage you wouldn't have to do if we linked into our frame analysis program, CADS A3D Max. The forces and geometry will all come from 3D Max. Indeed, the patterning is all done in here as well, so we'll come to that later on. You can see up here I've got the option to set up the design code I want to work to, BS8110 or Eurocode, and under the Eurocode we've got the annexes for the Irish Republic, the UK, and general EN. If you want to, if there's any need, you can actually then hit the user defined option and change any of the values that we've preset. Okay, so that's set the job up. The next stage will be the materials we're going to use. We've got types of cement there. We've got different aggregate types, sizes of aggregate. Indeed, the grade of concrete we're going to use for the beam. Reinforcement types, bond types, and so on. So those are all our materials set up. Now we're going to put the geometry in. We're going to do a 3-span continuous beam. It wants just to know the initial span lengths and whether or not it's knife edge or subframe. So we're going to choose knife edge 3 spans 6 meters, which is what I've got here. The reason it's not a problem if it's not this is that you've got all these tools in to edit that. We can drop some columns in if we want to put subframes in at any point, below or above, fixed or pinned. We've got an editing button here, so we can change our spans. Let's make that say 5 meters, and I'm going to make this interesting. We're going to have a 1.8 meter cantilever there. To make this a cantilever, I've still got the knife edge support there, so we go to free end. You can see fixed and knife and free end supports you can drop in, and also remove and add supports and spans. So we just click on the graphic and pop it in like so, and that's set up what it is we want to work to. The geometry it can be viewed here, so at the moment they're all the same. If I click on this span now, I can change the section, I can change the depth. Let's make this a deep beam, and then here I can choose the cross section. We can have boot beams, L-shaped, I-shaped, T-shaped beams, whatever you wish. I'm just doing rectangular beams here for now. The other two spans, if you hold your control key down, by the way, you can do them more at once, and we can make those say 500, like so. So that's the geometry I wanted to use. 5 meter, 6 meter, little sort of just under 2 meter span cantilever with a free end there, obviously, and knife edge support. So that's the frame geometry and the viewing buttons there. So working along, let's put the loads in. Now to put the loads in, we can choose a span and put its own loads on, or as in this case, if they're all the same, just select them all, go to where the loads option is, tell it you've got a new dead load to put in of say 15 kilonewtons, go OK, and then same for a live load, put a 10 kilonewton load in, like so. Now all that happens then is if you've got different loads on different spans, you create different tabs and then you drop them on by basically clicking here. If this is the initial stage where everything's got the same and you want to add another specific load to this span, you just go back to that span and put a point load in, for instance, if you've got something spanning onto it. So it can be very versatile. The combinations, they're set up for the Eurocode. You can see the factors there. That's the patterning it's going to do automatically, so it will do the alternate spans and so on. You can, if you wish, add another combination. And the other option we've got are sway loads. You can add those in either side of the columns. So we run the analysis, and very quickly we've got a bending moment envelope and a shear force envelope, very quick. You can see all the maximum values for each envelope if you go over the curves. These are sort of tooltips. And indeed there's a redistribution option too. You can redistribute up to 30% or by moment. Okay, so let's now move on to the design and the reinforcement cage. We haven't put in details of cover, so again, individually or selectively picking everything, we can go into this cover calculator in the program. So you can see the different exposure classes in the Eurocode here, and as you tab, you can see it changes the durability, the actual value that the code wants you to provide. You can see that there. So that's automatic, as is the adjustment for design life, uneven surfaces, abrasion of different types as well. The program will adjust for that. Fire prevention, again, you can choose whatever you need, and what the program will then do is work out which is needing the greater cover, and that's the value that you should then apply. And you can do that either to individual faces, you can see here, or we can just do it to all faces, or indeed it's possible to edit the cover yourselves and do it manually. The next stage is somewhat unique. What we're doing now, you can see on the screen, this is a default cage type. It's not the design, it's just showing you the arrangement of bars, and this is really, in the past with DXF years ago, this is why links to detailing was just not practical, because the cages weren't efficient enough, they weren't flexible enough from design to give a practical result. It's quicker to do it from scratch. We're trying to prevent that with this program, and you'll see why in a minute with all these options. If in certain parts of the world you use traditional crank, you can change from cage and splice to crank at a click of a button. You can see here that we can tell the program details such as do the bars run in the same layer or not, or alternate layers. We've got options for curtailment here, comprehensive rules so that you get lots of different bar lengths but a more efficient design, or you can just simplify that. And indeed you can go in and edit the inbuilt values that we've already got in the program. So if you hit new, we can change percentages, percentage of length that the curtailment runs to, number of steps, curtailment lengths and so on. So you can set that up yourself. The links that we're putting in here, now this is very, very specific for detailing. Different types of open link and closed link you can choose from, different types of links, full stops, concentric, singles, concertina. There's an option there for where the links start from and the rounding for the centers. The end bars, again, you can see here, this is sort of a default situation of a straight bar with an L bar lap to it. Now, people may say, well, for my particular instance, that's too many bar marks, so you could just put a U bar in, or indeed just bend the bars over. Entirely up to you how you want the cage to work. You can run this through to design, get a cage. If you don't like it, just come back, change this, and it will instantly give you another result. Very quick to make amendments. You've also then got the other difference between this program and many others. This does not require you to go through all the design zones, putting in bars. You don't have to tell it how many top and bottom and what links and then check it. You can if you want to, if it's an existing design you're checking, and you can do that. But if the user is doing a brand new design, the nice feature of this product is that you put in a range of bar sizes and that's it. Given all the other detail we're providing for types of cage, it will automatically give you a result. So these are the link sizes and the sidebars. We indeed provide sidebars for a certain depth of beam which you can put in. So that's why I've got this deep beam here. You can see I've put the sidebars in there now. You've got control here of maximum bar spacing, link spacing, and indeed even the spacing of the top bars, so that you can get a vibrator in to put the concrete in. Again, you can have dual here or single size bars in any layer, so you don't want to have too many different sizes in each layer. You can change it to single. We've got this other option. Now this is why I put a cantilever in. You can see here that anything below 2 meters, it will automatically take away the splice bar detail. If I turn this off, you can see what I would have had otherwise. Now you can manually adjust this. You just click on the bar and combine it through. That's what we've done many years ago, but now we've automated it so that anything under that span which you can put in, the program will take away that detail and give you a much more practical result. You've got other options here for bends in bars at cross beams and so on. Okay, so that's our cage. That's how we want the cage to look. The next step is the design parameters. We've got shear enhancement, capping, and moment capping, which is ideal for things like wide pile caps, for instance. But the shear enhancement and the slightly more conservative shear capping are there. Obviously, this is for taking account of the fact the shear capacity of the beam is going to enhance itself when it gets nearer the support. So we turn that on, we get an efficient cage. We can design for deflection. The span deflection ratios or values are put in here, and even for crack width. So we want to keep the crack width below 0.3 millimeters. Other options here: minimum lap control, curtailment percentages as before. So that's it. We're now at the reinforcement stage where it's going to give us a cage. Now we're thinking maybe people don't want to go that far. We're still working traditionally, so the first thing the program will do for you is give you areas of rebar required. You can obviously take this and give it to a detailer and detail that way. But these are the actual design zones and the maximum required rebar top and bottom. You can see I'm just clicking on each area and it gives me a result down the bottom. You can look at shear and bending, and you can take these values and obviously detail in a very traditional manner. But the other option is to go into this tab here. Now this is where it's showing us for each span, and you can see the supports here, here and here, and the free end. It's giving us the 3 design zones here, here and here. Now the detail you're looking at in this section below is the detail at this point here in green, and then the associative detail to the left and right of that. Now the T, B and L means the top, bottom and link bars can be edited. That's because at this point the detail on the right hand side of the column, remember there's a column there, the top bar is being governed by this side. Now you don't want the different bars either side of a column. I've seen programs that do that. Indeed you want the program to run the same bar straight through. So that's what's happening. This side is governing. So if I change, you can see I told it to have dual bars. Now you may want to change that. You go to the advanced mode in this panel, and you can say for the primary bars, they're in red, secondaries are in blue, I want a single size bar. So it's changed it now to 320. You see that's done it automatically. And it's also changed the detail on this side as well to match it. So you get a consistent detail. That's the whole purpose of that. So any of these sections where you've got a result from the computer here, it's also giving you other solutions that may work. Now some of them may be practical, some of them may not, but the point is it will give you, within the region of all the bar sizes we put in earlier, it will give you alternatives that work. So you can play with that here and see if it's a better solution or more practical. If you want to make all the mid-span details the same, you just wind around them, edit the detail, and they'll all be the same. The other way you could use this, rather than that automated solution is to go to user bars, and here we can simply drop in whatever we want to put in. So we can basically edit what's there and type in just exactly what we want to use. You may have an existing beam to check or something, and then you can run the calc that way. Or you may be designing with typical cages that you always use, ground beams and so on, that you just drop in, want to make sure they work. So we can create our own library of solutions here. You can see this is 16s top and bottom, and here I've got 16s with 20s in here. Look, there you go. And you can create these and save them. You can see you can create your own library. So you create them, save them, library. So several ways of working. Once we've achieved the detail we want, you then just click on Reinforcement Editor, and there's our final cage with all the curtailment rules applied. Obviously the anchorage lengths are all worked out too. You can have a look at what's come up with the slider here. It just gives you a cross section at the bottom to show you what the detail is, and indeed what that's also giving you, because of all these labels here, you can see where the bars begin and end, what length they are, what the link detail is, and so on. If you want to check a certain position, that's easily done. You just type in a length along the span. There we go. Now the other thing you can see in this view would be the efficiency of what you've designed. So if we go to the bending moment diagram, turn these cages off so it's clearer, you can see in green that's the capacity of the beam for bending, and then the blue is the actual bending moment diagram, and you can do the same for the shear. The green line is where there may be a warning for a detailing error, or indeed where you've put something in that doesn't work. As I said earlier, you can put your own detail in and check it. This will come up and show you where you've made a mistake. Indeed, if you want to move a bar, you can do that within the program. I'm just moving it mid-span and then say check, and you can see it saying capacity is way gone. I've actually moved the bar out of position, so if I check it again now, it's okay. The output from this, well, we can send this to CADS RC, and I'll show you that subsequently. But in terms of output document, let's go to print preview. All the different headings are here. You may want some of them or all of them, so you can choose them as you wish, or just add all. You can see the list there. The format can be comma or tab, which means you can send it to a spreadsheet. You can also export to Word. You've got an option here for preview, so let's just have a look and see what we get for this particular beam. So 1, 2, 3 spans, isn't it? So there's the 2 pages. We're up to 20 pages with everything. And if you want to, you can just tab down here and move through the document. We've got the input data, the bar assembly, the bar preferences, the loads, the combinations. Indeed, here you can see the pattern loading set up for you. We've got the elastic results in numbers. We've got the support moments and so here as well. The elastic graphs, it could be redistributed, as I said earlier. That's the bending moment shear force diagram. Tabulated results here too for the same thing for the envelopes. Then you've got the reinforcement detail for each span, and it gives here the top and bottom bars, what are required in each design zone. And then you've got the reinforcement details. This is the sketch of where the bars actually sit, cross section, and then the bending and shear force envelopes below. And then if you want to, you could just have the areas of reinforcement required and detail from that. Okay, now another format that may be useful is condensed. We had about 20 pages there. Let's go to condensed, and as you can see, I think we've got about 3 pages. So if I just bring this down a bit, you can see that's page 3 of 3. So for that whole detail that we've done there, it's only taken 3 pages in this condensed format. It's basically running down the page side by side. We can cut that right down to 3 pages. Okay, so we've created our beam. There's our detail. I think what we'll do next is just run that through into CADS RC later on to show you how this detail works from there. But what I want to show you now is how we can link this into our CADS A3D Max program. So this is now CADS A3D Max, our general frame analysis program. I want to show you how we can link RC Beam Designer to 2D, 3D frames of concrete that have been generated in this program, and avoid having to put the geometry and the loads into RCBD like I've just done there. So we've got this grillage. I'm looking at ground beams here. These are all sort of 600 by 450. They're 2835 concrete. This is about 5 meters, 2 or 3 meters long. The red areas are the supports. If I just turn the rendering off, you can see these little supports, and the analysis has been run, and we've got bending moments. You can see the labels here, and shear force, and obviously displacements and so on. So that's been run through. The combinations are all set up. That's all done in here. Eurocode combinations we set up and run, and it's really ready for us now to link through a chosen set of beams through to the RC beam designer. Now that's done by the user selecting what beams he wants to treat as one continuous beam. So we're going to have these three for now. The way the link works, you go to the design option, export to designers, and choose RC beam designer. It's the only one lit up, so you go to RC beam designer, and that's now taking through the loads from this program to the RC beam designer, where we had to put them in previously along with the geometry and everything else. So that saved all of this step here. In fact, if you go to view, we can turn the loads on. These are generated with area loads. That's why there's a trapezoid there. So back to the beam designer. If I click analysis, you can see the envelopes. So this has been created in an instant from the grillage analysis below. And we can see the shear force diagram and so on. So we're really where we were in the RC beam design at that stage. Here we can check out what type of curtailment rules we want to use, the bar preferences, what size bars we want to use. You might want to drop that down a bit from 35s and 32s. And all the cage arrangement exactly the same as we did. So we go through this process again, maybe shear enhancement. Once we've done that, we can look at areas if you want to detail this purely from areas. But then we get the reinforcement diagram again. We can edit these like we did before, and then we get the finished detail. These are quite short spans, so it's actually saying, do you want me to lap across the supports in certain instances? You can see the 7 bar here, but you see some of the bars are actually straddling across the support. You've got the 9 bar there, look, going across. So there we go, that's the finished detail. You can see we can move the section arrow, and exactly the same as before, but a lot quicker and very slick. There we go. So that's how we can link RC Beam Designer to the CADS A3D Max program. So here we are now in AutoCAD using CADS RC. For those of you who may not know what CADS RC is used for, it's a general RC detailing tool within AutoCAD that can be used to place bars inside any outline and get an automatic schedule and detailing. One of the benefits though is that it has got a link to the RC Beam Designer. Now I'm using the pop down menu here, by the way. There is a ribbon option if you wish to use it. So CADS RC Beam Designer. That's the beam I did at the very beginning from scratch, and then this is the ground beam we just did from the link from A3D Max. These are the 3 spans, look. Now I can also set this up pretty much as a company standard and save it. So how do you want to choose your cross sections? I'm going to do it myself rather than have 3 no matter what. Some of the spans are quite short, so it'd be useful. These are the offsets for elevations, section marker configuration, what layers do you want, what size, where do you want the labels for the links, for instance, and so on. And once you set these up, you can then write these to a prototype and never worry again. You just select your spans, go OK, and in comes the beam. So this is our ground beam. This is our first beam that we did. Let's call that beam 1. Now the other benefit of this little bit of work here is that we can put in how many we've got on site. Now in this case you probably only have 1 of these, but say it was a beam that repeats itself, so you can say here I've got 10. That will take care of the number in the schedule, save you having to duplicate this and copy and paste and so on. Those days are long gone. So here comes the detail. I'll explain this text in a minute. You've got the dimensions here. You've got a configured bubble for the grid. That can all be edited in terms of size and so on. The dimensions are here, as I said. The sections will appear down the bottom once I choose how far along the beam I want them to go. You can see I'm actually just digitizing a horizontal distance. The offset's programmed into the setting of the config for this, and you can choose as many or as few as you need. There we go. Now once you've done that, it says have you got any more. I'm going to say no. That's finished doing that. Pop it down on the sheet and we come out of the command. Now this text is basically saying if I haven't been removed, then the beam hasn't been checked, so we can remove that now and we're left with the detail. Now this isn't DXF, it's a little bit more intelligent than that. It means that These bars being live CADS RC bars, all the editing capabilities of CADS RC are still here. Typical Friday afternoon, if you've got to change the end of this beam by half a meter, you can stretch it and all the bars will update. Could be something you check on Monday, but it does mean you've got some flexibility of editing if this isn't exactly what you want, and the schedule will reflect all of the changes that you make to it. So here's the actual takeoff. That's the detail, all the automatic labeling, and you can see all the different bar shape codes here. These are all the bar marks and so on, the lengths and the weights. This is basically a database view. If you want to see the actual schedule report, then that would look like this. You can see it's compacted the bars for me. It's put them into member 1. And this sheet can be customized. So all the logos that you would have for your company can be included on here. The fonts, the size of text and everything, we can configure it. Okay, so there's one beam. So let's have another go and bring the other one in. It's RC Beam Designer. This one here, yep, that one. Go OK. Choose the spans. So I don't need to go into the other options now because all the settings for the layout have been done. We'll give this another name. You may have different numbers of these, or in this case what I want to do is separate the weighting that is automatically calculated for each beam. So I don't want the total weight, I want to know what the weight of each beam is separately. So I'm giving them a different member title so the program can help me to do that. See all the extra bars coming in here for the step that I've got because this is a deeper 750 beam. These are 500. Got the extra side bars there, look, coming up to the end there where I've got a little cantilever. Now we can take cross sections just as before. Not too worried about the vertical distance. Let's say that's all preset. There you go, the side bars are coming in, you can see that. There we go. Let's tell it we've had enough of putting cross sections in. Drop the beam down, suitable position, say there. And like we did before, we can get rid of the text and we're pretty much there. Let's have a look and see what's happened. You can see all the sidebars in there, the extra sidebars shown in the cross section. All the labels here, by the way, I mean, you can move these. They're not blocks or anything. You can pick a label here if you want to move it slightly. Not a problem. It's all very flexible, but gets you a great distance there in a very much quicker time. CADS RC schedule, and we can see the all the bars here now. We chose beam 2 as another member title. What we've actually got to do now is assign those bars to it. So we switch to member 2 or beam 2, and then using the mouse we just select those bars and we say apply, and that's now differentiated between the detail in each beam. So in the schedule you'll see that, as you can see, and also if I click to members you can see the weights are now separate as well. And indeed if you go to the example of the report that we've got here, you can see beam 1 and beam 2. There we go, CADS RC detailing, link from CADS RC Beam Designer. Oh, just to summarize then, we've been looking at the CADS RC Beam Designer, which is part of our Smart Designer suite. There are other videos coming up for columns, pile caps, pad bases and slabs. The RC Beam Designer, some key features. It can be used for continuous beams or ground beams, foundation work. It can be used standalone, or you can link it to CADS A3D Max. And it has a very comprehensive set of features for linking from analysis and design of RC beams into RC detailing and scheduling. We have other programs at CADS for concrete design. Different companies have different requirements in terms of either technical specification or maybe budget. So there's also CADS Hub. These are little individual programs. The one that I'm referring to there is the TR34 ground beam, ground bearing slabs, and then punching shear designer here. We have a link with the Duval company in Germany for full finite element concrete design. This is where you may want to put a whole building in 3D, look at the whole structure as a whole rather than just individual beams and columns. And as you can see, you can model some rather large buildings of very complicated shapes. The other programs we've got then are also Finite element based, these would be for raft foundations, piled rafts, and flat slabs, 2D flat slabs if you don't want to do the whole building. And these slabs, again, they have a link into the CADS RC system and also to RC 3D in Revit, which is a new program. Thank you very much for listening. CADS RC Beam Designer is a program that we've had a lot of fun developing. I hope you can find some time to try it out. If not, maybe invest. If you want to find out any more, give us a call on the number here, or send us an email, or even go on our website and see if there's anything else you might be interested in. We'd be very happy to help you. Thank you very much for listening. Speak to you again soon. Thank you.